Hello friends, welcome back. Today I am going to discuss this embedded debugging concepts. Myself Sanjay, and I have discussed Linux dynamic library and GDB in the last blog. I strongly recommend you to read earlier blogs for better understanding. If you find something missing, please provide feedback in comment box so that I can take corrective action. So GDB utilizes system called ptrace to fetch required information. This particular discussion is limited to native debugging using x86-64 architecture. We will be debugging that embedded platform later, but all the concepts are similar, and whether you are using GDB or any other debugger, so basic things will be similar. So what are the basic things? Step by step debugging. So one way, you know, that you have traditional way of debugging using print command, and but it is not always practical to use print command, you, you know, when problem is somewhere deep inside that code. So step by step debugging is required. So step by step debugging, what can be the step by step debugging? Let me show you that source file here. Let me cat hello.c, that source file here. So source level, suppose instruction statement by statement at source level, it will go, let's say, first this particular point, then it will step to this one, then it will step to this one, that is called step. Okay, so one by one. So in this case, but in between it will go inside this also, that, and it is called step in. So step, this particular step command is basically step in. So it will execute this, then come here, go inside this function. But if we don't want that, then we can use next command. So instead of step, if we use next command, then it will first execute this one, then this particular second statement, and simply jump to the next one. Okay, so not go inside the square root function. Suppose if you go inside square root function by mistake or to analyze something there, so then you can also step out using the finish command from there. And assembly level, you have to use this step I, or you can simply use si, and top you can simply use s, and next I for similar way like step over at assembly instruction. So in assembly instruction, what is the step over? Means that if you are to step some call function, let's say some function call is there in the assembly, then if you want to step over that, you don't want to go to inside that call function, then, and program counter you can print using this command. So I am going to show you this once we first understand that what all features are available, and where command will provide you that where exactly your code is right now. And you can always use list or disassembly command to view that C code or the assembly. So this is related to that step by step debugging. In that second thing is, once you are debugging, definitely you need to analyze different variables. So you can use info locals for local variables and all those kind of things. You can change the variables. If here, for example, you want to check it at the boundary, so you can make number 90 or whatever you want to change that, so to see the flow at the last. And you can use simple print number in the GDB, it will print the number. And you can also use the printf normally C kind of format here within the GDB. And for the registers, you can use info register, info all registers, Yeah, this will be like some main registers, and this info all complete register including floating point, everything for x86 platform and any other platform. Also similar approach is there. And print and dollar register name, for example register name PC, so PC you can put dollar PC, and you can change that register value using this particular command. Suppose you have to skip some particular instruction, so you can change PC or another any other instruction. Memory, if you want to see some memory is accessible to you at user level, so you can use this particular command. And stack frame, so this is the interesting one. So let me first go up to this particular point. Okay, we have to see the breakpoint also. After that I will go stack frame. What is the stack frame? Once you go inside any function, let's say if you are going inside this particular square root function, so you are passing it a parameter. What parameter you are passing? You are passing the number parameter. Okay, so this particular parameter and also the local variable inside that function, all those things, and where it has to return, all those things it is stored in the stack, and that is called the stack frame of the function. Okay, so when we use the backtrace command, it gives that stack, it gives basically that sequence with the current one will be the first current one. It will show you like wherever it is right now, it will show you that one first. Okay, and then the older one. So this I will show you, and let me first go to this quickly. GDB hello, and whatever the command I have to, this is the executable. Inside this, let me put a breakpoint at main and run it, or continue through that. Oh, program is not run, not being run, so let me run it. It will stop there, and let me simply step inside, step. So it is going inside the square root function. It has come out of that also, I believe. Then it has stopped because of the hold. Let me do Control C to quit out of this and set hold equal to 0, so that we can move further. Step, let it go inside printf command, and it is inside this bprintfc command. So it is right now inside bprintfc. Let's see backtrace. So what it is showing, bprintfc is the top, and it was called by the second one, and this was called by the third one. If I use this particular info frame, so it will give me information about this current frame, info frame. So current stack frame, it is showing info stack label, this one 0. What is the stack label 0? What is the current one? 0. Okay, suppose if you would like to check that at this point 2, so you can do directly. If you write frame, it will always give the whatever that current set 0. You can put frame 2, it will give you second one. So second one, you can see the printf related second frame. And here if you use that info locals, it will give the local values, and argument, if there will be any argument, then it will go give, otherwise it will not give. Okay, so that's why you can see that, and you can always change that. If I use the info frame, whatever the current set I have, it will give that one. If I use again frame equal frame 0, then it will set and select display that one frame 0. Breakpoint. Breakpoint is most important thing in this debugging, because if this is this kind of small this code is it hardly, if I list this, so few lines are there, it is inside printf. So let me continue at let it okay, it has come out of this. Let me list main. Okay, so it's small code, so you can play with step in, step over, step out. But if it is thousands of lines of course, different files, like you are going to debug Linux, so this will be very time consuming. So in that case, you need something that you stop it a particular function and then analyze that particular function. So there you need breakpoint. So there are two kinds of breakpoint in every architecture, every debugger. Wherever you go, whether it is GDB or anywhere, you will find two kind of breakpoints. One is hardware breakpoint, another is software breakpoint. So software breakpoint basically depends on the debugger implementation. Why? Because the theory, the software breakpoint, I can share one example the debugger may implement. For example, like at the particular wherever you put a breakpoint, that instruction it will replace by some other instruction which can throw exception. For example, trap. Okay, it depends on the debugger and architecture implementation. So whatever exception it is using for that particular purpose, then as soon as your program executes and move to that particular point, it will throw the exception. Okay, then within the exception handler, basically debugger will stop this execution, and then you can verify. Other thing, debugger will provide you all the information related to that. And but one thing is here, like, because you are replacing the instruction, what does that mean? It means that address where you are putting the breakpoint should be read or writable, and breakpoint you put always in the instruction program memory. Okay, so if it is in a flash and executing from flash, not in the RAM, and the memory where you can put a breakpoint, so what will happen? You will be not able to use the software breakpoint. Other thing is, because this software breakpoint you are simply replacing the instructions, so there is no limit, only limit your RAM memory size. So if it is read only memory, the next solution to that is hardware breakpoint. What is the hardware breakpoint? Software breakpoint was debugger implementation. Hardware breakpoint is the device core architecture implementation. It means it used to have some registers for this purpose, some for instruction related, some for data related. So instruction specific register, or some architecture, for example x86 use the debug registers. So once that your address where once you put a breakpoint, hardware breakpoint, it will not replace the instruction, but it will put that in that condition in the particular debug register. So as soon as the instruction address matches that, then execution will be halt by the architecture itself. It will halt there, and then you can play with that. So because this is registered architecture dependent, number of registers are limited, so that's why you will be having some limit on the hardware breakpoint, maybe 2, 4, depending on the architecture. So but you have the solution. Okay, you can always use simply break command, break function name and all that. Info break will give you the list, and by default, if you set a breakpoint, it may be hardware by default. Okay, sometime maybe it is it depends like what is the setting. So this setting, always default setting, you can always change. So in this particular case, like auto hardware is off, so it means that uh, it means that by default it will not set the hardware breakpoint, it will set the software breakpoint. So for setting hardware breakpoint, you have to use the hbreak, hardware break. Okay, so that we will see here. Let's say if we are going to put a breakpoint at this condition, let's say you are going to put a breakpoint at 9 is already there. Let me see the okay, I am going to put at 13. Break 13. Okay. Now, if I info breakpoint, it gives like 2 breakpoint, and address also you can match from here, or if you want you can always, this is showing the 13, you know, here this particular thing. And no hardware breakpoint. And let me check if I can put hardware breakpoint hbreak 11. Oh, support to that. No, it is not possible. It has the support, or it has used that. I will check that later. And let me run it first. Continue. Why it is showing that? Oh, that program is not being run. That's why it is showing this thing. Let me first run it. Okay, now list where it is, and we can always print, you know, where we are. Okay, main, this is this, and let me now try hbreak and 11. That's it, because it was not executing, that's why it was showing that particular you know, error. So hardware breakpoint, software breakpoint, we know that both are there now. If I run, then it will go to that particular thing. Okay, if I here continue, then it will stop particular point. So breakpoint will hit, it will stop there. Right now hardware breakpoint hit. Okay, so temporary breakpoint, what is the temporary? We use a T break. T break, if you use that, then it will be automatically deleted. Right now you can see that although that breakpoint is hit, if I see that breakpoint is already hit one time, but it has not deleted. So if you need some breakpoint only for one problem, let's say you want to go to main and only one, so you can use temporary breakpoint. Why to waste software breakpoint or hardware breakpoint, especially software breakpoint? Anyway, there is no limit, but it is like always botheration to delete that later if you are going to analyze the complete program. That is also possible. Okay, then this is wrong. This should be hbreak actually. Okay, then break if condition. So this is the typo here, hbreak it should be. So break if condition. Suppose right now let me see that number. What is the number value right now? Number is only 1. So let's see if I can stop it as when it is 5. If I right now, if I continue, and if I continue, it has stopped because right now my hold value is 1. Let me make it 0 so that it can continue. Okay, now let's see what is the number now. Still 1 or now 2. Okay, so anyway it is stopping at that, or maybe info locals if I use that. So 2, number equal to 2. So I would like to stop it only at 5. So what I can do, break if number equal to 5. Fine, unless there is a hardware breakpoint, it will not stop, and if it is stopped, then we will anyway remove that first. So let's see what is that number right now. Print number 2. Why? Because we have another breakpoint also. So if we are going to remove another breakpoint, so we have to, let me clear and see breakpoint I B. Let me delete. I can delete also. Delete 1, delete 3, and last one. If I use now IB, this is now 5. Okay. What is the number value right now? Print number 2. Okay. Let's continue. What is the number value right now? 5. So it is stopped at the 5. So that is the conditional breakpoint. And it is also possible to put a breakpoint at the any particular address. Let's say if you are doing disassembly. So right now it is at this particular point. If you want to stop it, let's say this particular point. So what you need to do, break, and this, let's say I am going to stop it just before calling this function, or maybe yeah, this one. Okay, then you have to hash paste address and continue. Okay, then it stopped there, and that is the disassembly. Oh, this should be correct. Okay, right now it is going to inside call queue. If I use instruction si, then only I believe it will go. So you can see inside this jump it is doing inside that particular. So PLT is like, it is like right now we will go to, address resolution, which I discussed earlier for shared library. So that is also possible. Okay. So we have seen like instruction, we have multiple ways. We can put breakpoint, conditional breakpoint, we can put hardware breakpoint, we can put software breakpoint, we can put breakpoint at the assembly level, everything. Watchpoint. Watchpoint, what about the data? Data, one case we have seen, for example, number was changed, so number was 5, compared, so it stopped, instruction execution halted. But if I would like to simply set it simply number XX. Okay, so I will again try, let's see, I will remove all other condition, delete, let's say, let me try, it depends on the stack frame. So it is not, because right now it's not there, so we can always try delete command should always work, no problem. Then oh, I 3 is not there, 4 is there, so I can check. Fine, no breakpoint. Now what I want to put a watch point when that particular variable access data. So a watch number, whenever it was access, constant value cannot watch, where it is, just a moment, let me check where it is. Step, it is somewhere here, let me come out of this. I should be able to see at least the local variable number is there. So now a watch number, fine, because earlier it was not in this range, so that's why it was inside the library, it was not allowing. Okay, so when I return back from that particular library function and within that stack frame, my stack frame, then it is allowing, and now I can always see using this. and let's continue. Okay, stop, because that particular number is just accessed. You can see here, just access, not in fact change. Here it is getting changed, so both read write is happening. Here it is, again one time read write, again here access. So if I am going to, suppose if I want simply, first of all I will delete this one also. Suppose if I want simply to put that breakpoint when somebody change it, not every time, only accessing should not. So what I can do, I have to, watch point, then we have to watch this particular register, that it is getting changed. Okay, then continue. It will stop there only, because that is the only place it is getting changed, not at the another place. So we have that method to see when somebody change it. We have a method to halt the execution when somebody access it. We have a method to halt the execution if some specific condition is there. So that is the breakpoint condition bit, if breakpoint. What is the catch point? Apart from hardware, software, breakpoint, watchpoint, catch point is for specific to some event. Suppose some system call is there. So I don't know when system call will happen. So you can put always this catch syscall, or maybe any module loading and all that. So if you run it, continue, it will stop as soon as that will happen. And again I will check my all this list and delete one by one, because so that we can do another experiment. Okay, info v will list that catch also. Anyway, we have seen that already, info v, and delete will delete that. That's not a good thing. Attaching to running process. This is very important concept in the debugging. So far, whatever we have seen, that we started the execution of the application through the GDB. Okay, and then then we only put breakpoint everything. But many times what will happen, that you get some crash in the running kernel, you get some crash, some error in the any code, or you have to analyze a particular waveform and that is not happening at the runtime. You'd like to check the value of the runtime, and you don't want to control from the beginning itself. So that's why attaching means without disturbing the running program, that concept. Let's come out of this. What we will do right now, we will run it simply. Hello. So this is the reason I put, actually, if you I will share you that that thing. Normally if I, oh sorry, PS, let me check if some, okay, let me, okay, I can use this one also, I think 3671, or let me kill simply this one so that I can use a fresh one. PS, okay, then I would like to run it like this, 3865. So if I share the program here, I put this particular condition and hold equal to 1. So why I put this condition? Because if you don't put this particular condition, it will simply execute this, come out of this. So you will be not able to attach. Suppose some problem with this square root function. I want to analyze that value immediately after that. Okay, so anything, it can be anything like. So that's why I put this. I didn't put while one, because most of the time, many times what happens, the compiler will optimize this, because as per compiler it is while 1, so it should not anyway execute beyond this, so it will optimize, so that will not solve my problem here. I would like to stop here, so that's why I put this particular breakpoint. So it has anyway stopped there, so that we can check using the command sudo I have to use, because I would like to attach to that particular process. So for process level I need the sudo permission, then GDB attach, and 3865, and I need to put my breakpoint, my password, and oh, something typo. I have to put 3865, I believe. Exactly. So it stopped at the same point. If you see that list here, and if you see the disassembly, now if you have to try something, you can try that thing, or if simply you want to change the program counter, there are two ways to do that. Number one, you simply change that value of this particular, you know, whatever the variable, this hold equal to 0. And suppose if you are using while one, your compiler is not optimizing that, you have set some optimization label that it will not optimize, so in that case while one also you can use. So in that particular case you have to change the program counter, or you want to suppose skip certain instructions, so in that case also changing the program counter may help. Let me see what is the program counter right now. Program counter is this one, and this is the condition, this is that again jump not equal in this. So I would like to see this particular instructions. Let me go to this particular, okay. So, or is there any call or something? Or let's go first this one, 658. So let me note down this address, and what I need to do, I need to simply set program counter equal to 0x and the whatever the address I have taken. Fine. And I can verify again program counter school. Then I can put a breakpoint at this location, 66 another location, just for another experiment. So I will put a breakpoint, and I told you to put a breakpoint I need to use this for assembly level. You can always check that. Then continue. So what happened? It is at 667 or that address. So I would like to go inside this call queue in the assembly. So which instruction I have to use? Just a moment. It has, I think, program counter did not change, or it has come again the while to while. Program counter was changed, but it came again to that thing. So that's why while one, so probably I have to check exactly whether it will come here or not. So it is right now 656 where I need to come. 656 658 is this assembly level is sometime RBP, not sure exactly. Why it is stopping there? Because we need to, it still at the hold. Okay. Breakpoint is there. Breakpoint is there. Breakpoint is there. And what is the program counter right now? Let me see program counter. Program counter 652. 652 is our 652 is this thing. So we have to put 6. This is the address. Let me put the complete address. Should not matter whether I put that one or, but let me put the complete and breakpoint star and this address. Okay, then I have to assembly label step in 656. It is oh, breakpoint. Instead of breakpoint I have to change that program counter, sorry, program counter to that value, and that is simply this value. So print program counter, we will see whether this program counter has changed, but whether it goes to next or it comes back, that we need to check. So again I will check the program counter, because there we have put a breakpoint also, that's why it is creating problem now. So delete which breakpoint? 658 breakpoint, delete 2. We have to remove this. Okay, then again now 65D, it has moved further. So if you see that disassembly here, it has moved here. Now it should go up to this. If we have 66C, we have breakpoint at that. If we have IB 66C, no, we don't have breakpoint at that point. So we have to set a breakpoint at 66C. That's why probably last time it did not stop. 66C, make pending on future, not define. Oh, we have to use star. Okay, then let's try continue. It stopped there. Okay, now disassembly 66C, it has stopped. 7, it has stopped, and I would like to go inside this call queue. Let's say single stop, single step, single step. Now it is going inside that. Or here if I see back trace, so you will see like it is inside that particular. Okay, so that's that way basically this debug attached the runtime it works. Okay, and I have provided frequently used GDB commands, because there are lot of GDB commands, and when we will be working on particular target, embedded target, so not sure how many commands will be supported in that particular target, but so that's why I provided the frequently used one. And thanks for your time. Please don't forget to subscribe this YouTube channel Embedkari, and if you are interested or looking for open source tools and technology, check out this particular website, findbestopensource.com. Okay, thanks.